a senior consultant at Glintech, and I want to talk today about Data Center and how it can help you in your organisation. But first, I want to talk about a few of the other implementations that you can use. Let's set the scene. So we've got cloud. So cloud and what these different implementations are good for and where the weaknesses are. So we've got cloud. So one of the great things about cloud is that it's hosted by Atlassian, so there's no infrastructure maintenance. You don't have to worry about it. You can just put it on there and not worry. But you don't have access to any of the files of the database behind, and there's a user cap of about 2,000. Next one over is server. So this is where you control your infrastructure. You deploy the Atlassian product on your own server and your own infrastructure, which is great because you have control over that data and over that infrastructure yourself. You can also use Active Directory and other authentication methods to authenticate users through there. But lastly, the one that we want to talk about today is Data Center. So that's moving from a single server to a cluster of nodes and having that there. So why would you be interested in moving to Data Center? And there's three factors that I want to talk about. So growth, performance, and downtime. And the first one is growth. I think Robin touched on a little bit about it before. We're talking about users. If you're seeing that your number of users is over 500, that's probably when you want to start thinking, and maybe an impetus to start thinking about moving to Data Center. But that's not the only metric that you're having a look at for growth. You're also having a look at configurations and workflows. Those things may cause you to start looking at Data Center moving to something like that. Then there's performance. As your organization grows, as your usage in an Atlassian application grows, you may find that your performance starts to degrade. And it may be time to start looking at Data Center to help you improve your performance. And then at the end, there's downtime. How much downtime is acceptable in your organization? You have to think, you may want to think about it as in every time that my Atlassian application is down, how much does that cost me? How much does it cost that my devs can't actually do any work at the moment or can't actually log any of their work, or there's no collaboration in Confluence? So how much is acceptable to downtime and how much does it cost your organization? If you're thinking about these three pain points, you may start thinking about moving to Data Center and how that helps you there. And what are the key features of Data Center that they bring to your organization that will help with those three pain points? So I've got 6 here that I want to talk about, and they're high availability, redundancy, load balancing, disaster recovery, quality of service targets, and I've got zero downtime upgrades, so we can talk a little bit about that. So high availability minimizes downtimes and interruptions through active-active clustering. I'll talk a little bit about that in the next slide. Redundancy. Redundancy minimizes single points of failure through shared database and file system. Disaster recovery to ensure your business continuity through system or local outages that you find. Load balancing helps maintain consistent performance through intelligent load distribution. Quality of service targets, so support quality of service targets through dedicated nodes. And I think Robin touched a little bit about how one bad REST API query can cripple your application. We'll talk through how Data Center might actually help you there and those quality of service targets. And then zero downtime upgrades, so minimizing the need for your application to be for your downtime, but also through those outages that you may occur. First one I want to talk about is the active-active clustering that I mentioned that's available through the high availability. So active-active clustering ensures uninterrupted access to critical applications in the event of a hardware failure. And how does it do that? This cute little slide here, I didn't make this graphic, so I'm not going to claim ownership, but it's brilliant in showing you the infrastructure of how you would set up Data Center. So you have your organization's network, and your organization's network accesses your application, and the entry point is through the load balancer. We can talk about that a little bit later. But then we've got our cluster of nodes, and here's where we're talking about active-active clustering. So each one of these nodes is actually an application instance. So you may have a Jira instance, and you'll have your Jira instance replicated across each 4 of these nodes. And so what happens is each of them is active at the same time. And then your load balancer can send through your requests depending on which node is active and available and ready to serve your requests. So that's what it means by that active-active clustering. Next, I want to talk about redundancy, so minimizing single points of failure and how Data Center does that. So Data Center deployments integrate with industry standard technologies for database clustering and shared file systems to minimize single points of failure, which is up to your organization as to the solution to implement. So if we have a look here, and on that previous slide where I'm talking about, we've got those nodes, all those active nodes, and those connect through to the shared database and the shared file system. So those are off, but you can use like clustering databases that allow you to have that high availability, and Data Center can access them through that. Now I get to load balancing. So intelligently distribute load across your data center cluster using the load balancing solution. So this is the one that kind of helps you. You've got your active nodes. They're ready to serve your requests, but how does it know which node to actually ask for that request and how to actually help your performance because you're not hitting the one instance all at the same time. So load balancing gets those requests. And through so Data Center is a load balancer agnostic. So you may have a preference in your organization for one load balancer or another. Data Center can integrate with that. And then depending on your configuration and how you want to use it. I've put a few there, so round robin, least connection, and IP hash. So something like round robin, where the load balancer gets a request, and then it'll send it off to node number 1. And then the next request gets sent to node number 2, and then node number 3, and it keeps going in a round-robin way. So that's one way that your load balancer may kind of send those requests out and make sure that each of the nodes is working for you, but no node is working over time. Disaster recovery. So this is a big one. So disaster recovery ensures business continuity, even in the face of complete system or location outage. So depending on your organizations, you may want to minimize downtime, and then you may think about an acceptable restore point. So how much downtime can we have? So you're going to think in your organization, you're going to have a disaster recovery strategy, and you're going to have your objectives there, like how much downtime we can have and what's an acceptable restore point. So Data Center allows you to configure that and have a particular configuration to implement your disaster recovery strategy. And this is the only slide where I've got animation, so I really want to check it out. Slides in. Awesome. So what happens is you'll have your primary site, and that'll be your whole implementation of Data Center. But you may have a secondary site, which is your disaster recovery site. So that would be on standby. And what Data Center does is that it's got tools to assist with data replication across those locations. Because you've got that acceptable restore point that you need to think about. How often do you need that data copied over and that data synchronized? So DC has those tools that helps you replicate your indexes and replicate your database and file shares across those two locations. But it may be that your remote site, your standby site's not on all the time, and when you have an incident, then you have that failover where you switch, you turn up you start up your standby instance, and because the index has been replicated, that startup time is greatly reduced. You'll set up your standby, you'll start it up in the event of a disaster, and then switch over your customers from one site to another, and hopefully most of your customers have not realised there's been an outage. Quality of service targets. So dedicate nodes for automated tasks, API calls, and more. Maybe maybe have one box that's an admin box to ensure highest possible quality of service for critical teams within the organisation. And like Robin said, one person can type an instance with a bad query. How do we implement quality of service targets? Through our load balancer. We make sure that our load balancer can identify particular types of traffic. Maybe you're identifying REST API calls, and you know that they're problematic in your organisation. Maybe you want to have one node that's dedicated to that REST API. So all those other nodes are going to have problems serving normal requests from other users. And this is how it would happen. So yeah. And lastly, zero downtime upgrades. So at the moment, zero downtime for upgrades is only available in Jira. In Confluence, there's a read-only mode. So if you're upgrading, people can still read through, but they won't be able to edit things. But what this does is you can upgrade your nodes with no downtime. If you think about it, you've got, say, 4 nodes in your organisation. Maybe you start upgrading on one, and the other 3 are serving requests. And then at some point, you can switch over to the new upgraded version, and hopefully your users haven't seen any performance hit or anything. I want to talk about instant scalability. this is one of the great things about Data Center is that you've got hassle-free deployments. So we talked about those active-active clustering, those nodes. You can set it up so that you can add nodes if you need to. If you're seeing a performance hit, you can add nodes without any downtime. New nodes can join the cluster, and existing nodes can automatically sync indexes and plugins with each of the new members. You have rapid re-indexing, so quickly re-index your application without locking or slowing down the system. I know a lot of times we've made changes to an instance in Jira and we either wait to re-index for later or we have to ask people to stop and it slows down the instance. So this is one of the great things about Data Center is that you can make those changes and re-index and no one's going to find any issues there. And predictable costs. So you can scale your environment without any additional license costs. Obviously there's costs for infrastructure and new nodes setting up, but a Data Center deployment option, it's licensed by user account and not by number of servers or CPUs. Now, when we're talking about Data Center, we're actually talking about a family of products that Atlassian provides. And these are the different products that have a Data Center flavor to them. So we've got Jira Software, so our project and issue tracking software. We've got Jira Service Desk, so IT and business service desk. Confluence for document collaboration. Bitbucket for your Git code management. HipChat for your team chat, video and file sharing. And Crowd, so single sign-on and identity management. So I'll just quickly touch on some of the features that may be specific to each of those applications if they have them. So have Jira. So you have licensing starting at 500 users. Jira Data Center has health check. Sorry, let me quickly say Jira, we're talking about Jira Software and Jira Service Desk together. It's got health check tools that help determine the health and status of each of the nodes. Because that's kind of vital when you're having a look at adding nodes or changing that around. And then lastly, I want to talk about project archiving coming to Jira Data Center 7.10. So this is a really cool new feature that's coming. You can archive a project, and after you archive a project, it will be removed from the list of projects, project pickers, and search results. Both you and your users won't be able to access the project itself, but you'll be able to view all the issues from an archive project if they're mentioned or linked in other projects. And these issues will be read-only. So all data related to an archive project will remain in the database, and you can restore the project whenever you need it again. So this is really great where if your organization you need to retain that data, but you want to clean up your instance and you want to make sure that it's nice and streamlined, you can archive that project in the new version, in upcoming 7.10, still keep that data, still be able to link between them, but not have it mess up your instance. And Confluence. So Confluence, again, as well, licensing starts at 500 users. Uses a distributed cache that's evenly partitioned across all nodes. Synchrony. So Synchrony is the software that allows for that collaborative editing. You can either have that on the cluster of nodes that Confluence is deployed onto, or it could be on a separate node. And then the one thing that you need to make sure, especially for Jira and for Confluence, is that the Atlassian Marketplace, not all the add-ons that are for server will also be compatible with Data Center. So make sure to check your instance, to check the Atlassian Marketplace for compatibility there, because that's one of the big gotchas. The last application that I want to touch on specifically is Bitbucket. And Bitbucket has a really cool feature called Smart Mirroring. So it may be that you have co-located teams or your data center is not geographically close to your organization or your developers. And so Bitbucket provides smart mirroring, where you'll be able to do cloning, fetching, and pulling, where it synchronizes. You've got your primary site where your data center application is, and then you may have a smart mirror server that's closer to your organization in geography, so you've got low latency, or you may have co-located teams. So here we've got a Sydney team and an Austin team, and it may be that the Sydney team is the primary site, the Austin team is the secondary. When you're cloning and fetching code, you don't want that latency interrupting your work. So what you would do is you'd have your smart mirror and they can clone and fetch from there, which reduces that time, and then when you're ready to push your code off, you'll push it off to the smart mirror, or to the primary site, and that'll synchronize between them. You can deploy as many smart mirrors as you want to accommodate your geographically distributed teams. I want to talk about two pieces of software or integrations that aren't necessarily Atlassian, but integrate really well with Atlassian data center products. So the first one is Atlassian on AWS. So AWS provides quick start guides powered by AWS CloudFormation templates for Atlassian so that you can deploy your data center cluster in a few minutes. It's really good. I tried this the other day and it's a lot of fun. So this includes like load balancers, databases, and all the connectivity needed. These guides include configuration steps and best practices so that the teams can take advantage of AWS's elastic capabilities like auto-scaling and instant provisioning. And these capabilities enable you to easily scale your data center to meet your growing demand. One of the things you may want to check though is that these are highly spec'd instances. So if you're testing it out, you may want to make sure that you check you're not having it on too long because it can increase your bill. Here's a quick kind of sample of a Jira CloudFormation template where it's automatically deployed Jira in a bunch of nodes. It's given me a Postgres database. It's given me that shared file system. It's provided a load balancer there, all for me, all very easily and all deployed in a few minutes. Lastly, I'm going to talk about SAML. So many organizations may be using SAML for single secure sign-on across the products their teams use every day. SAML and SSO support in data center enables customers easy access across all mission-critical Atlassian applications. So your users now have fewer passwords to remember and your admins have fewer password resets to do. With SAML 2.0, admins can specify a SAML provider to manage user authentication. So data center supports popular providers like Okta, OneLogin, Azure, and there's a bunch more. Why would you move to data center? We talked about that. Now I want to talk about how you would actually decide or how you would actually migrate over from a server to a data center implementation. Because the one thing to remember is that it's not just a quick and easy. There's a fair bit of project work that's required, especially if you have that, you're moving because you've got performance or you've got many users in place. So the first one that we'd have a look at is building your project team. Take it seriously and approach it like a project. Make sure that you have all the right people involved. You'd need to bring in the right people, communicate the changes, and you need all the right stakeholders because there's going to be decisions that are coming up later on that you need those stakeholders on board for, and there may be some interruption as you're migrating over. And one of the big things is you want to agree on the goals. Why are you moving over to data center? Because that will inform how you configure your implementation. You may have more nodes, or you may have a focus on databases connecting. You may want to make sure that you've got directing traffic through to particular nodes, that kind of thing. So make sure that you agree on the goals really early on so that those decisions that come up later are really easy to make. Next up, it's very important to review your current installation. So gather metrics about performance. I guess the first way is to know when you're actually having success. So if you know where your baseline is, as you're upgrading, as you're moving over, as you're testing, you know, yes, we're seeing an increase in performance, or no, we need to tweak some things and we need to go back and make sure that we're getting our wins. The other thing is cleaning up your server. So Robin talked about having too many workflows, having too many custom fields. Those things aren't going to magically be solved by data center because you still have each of those application nodes still doing your thing. So you want to make sure that you're cleaning it up and that you implement some governance right from the beginning so that as you move to data center, you don't just introduce the same errors that you were having before. Put restrictions on how it's accessed if there are no restrictions at the moment. And make sure to review your add-ons because, again, as we're saying, not all your add-ons will be compatible or may be compatible when you're moving from server to data center. Document the current process. So now that you've cleaned up your server, now that you've introduced governance, you want to document it because you want that to continue on when you're moving or migrating to your data center. And then evaluate your tech decisions. So we've already done 3 steps before we're actually thinking about the technology. So what kind of load balancer do you want to be using? Nodes, how many nodes do you want to have? Do you need software configuration management? Do you want to install Puppet and have that do it automatically for you? These are all the considerations that you may want to have a think about before you're actually migrating over. And then you've also got to think about your database and your file system and how that works in your organization. Because it may be that someone says this is the best, but if your organization isn't set up for that, that might not be the best decision for your organization. So have a look at all of these decisions in the context of your organization and what skills you have available there. And then lastly, implement, test, and deploy. Make sure that you're doing that circle of you're implementing it, you're testing it, you may need to refine it and go back and then re-implement it before you actually make it live. And this is where all our decisions before, how we got our measurements, this is where we can see, yes, we've had some success, we're seeing some great performance results, and everyone's happy.